So we'll start off with Dr. Winnie Courtene-Jones, who's a Post-Doctoral Research Fellow at University of Plymouth. So, Winnie, there you are. Sorry, we introduced ourselves earlier. Winnie, it's all yours.
Excellent. Great, thank you so much. I'm delighted to be here and following that fantastic opening presentation. So yeah, my name's Winnie Courtene-Jones and I'm a researcher into plastic pollution at the University of Plymouth. I've been working on plastics for about 8 years now, and within the last couple of years specifically focusing on biodegradables. So I just want to give kind of an overview, setting the scene about biodegradable plastics in the environment. So as a little bit of background first about general plastic use. I'm sure that we've all sort of seen and aware of the global trend of plastics kind of increasing over the last few decades, and it really has sort of skyrocketed. There's also now substantial evidence that indicates that plastics are accumulating in the environment and within different waste systems. And that combined, we've already heard about Blue Planet, but these graphic images have really put it into the minds of the general public. And there's been a pressure from them, from bottom up, but also top down with industry and other stakeholder groups also calling for change to the way that we're doing things. And one of the sort of alternatives are biodegradable and bio-based plastics. Now these aren't new, these have been on the market for over 100 years, but because of a variety of different economic opportunities, societal pressures and different environmental drivers, really within the last few decades, the use and consumption of these alternatives has increased. You can see here that it's just projected to continue increasing. I might add that overall this makes up a very small amount of the total plastics. So biodegradable and bio-based plastics only make up around 0.5% of the global plastic production. So it's still relatively small, but this trend is kind of increasing and is projected to continue increasing. Okay, now I've just mentioned these sort of terms, biodegradable, bio-based plastics, but what do they actually mean? And it is something that's a little bit tricky to kind of wrap our head around, even for someone working in this field. And also, but understanding what these terms mean is really important, and it's actually been shown from the general public that there's a lot of confusion over these terms and kind of a knee-jerk reaction to seeing that bio at the start of the word, and the public and people that want to do the right thing thinking that this is a green, sustainable option. So let's just look at this, this figure you can see there. So we've got at the top, let's focus on the two horizontal categories first. At the top we've got bio-based plastics. So these are made of plant or biomass feedstock. And they can be biodegradable and they can be non-degradable. So the two don't equal the same. Bio-based does not equal biodegradable. And the same for the fossil-based at the bottom of the screen. You can see these are petrochemical-based plastics. And again, these can be biodegradable, but they can also be non-biodegradable. Biodegradability is more of a system property. It's a function of that plastic, rather than necessarily meaning that it's come from biomass. So if we think about, we've already seen this figure of the waste hierarchy, and based on those sort of principles of resource efficiency and the waste hierarchy, really the best option is at the top. So it's to reduce and reuse and recycle a material. If we think about biodegradability, that's automatically a disposal pathway. So we're on our sort of least favourable option. But in certain circumstances, this might still be favourable. And this report came out in 2020, a couple of years ago now, and it's the European Commission report that brought together a huge number of scientists from across the world to put together a state-of-the-art, all evidence summary of biodegradable plastics. And what they came to was that in certain circumstances, biodegradability might make sense and might be favourable over conventional plastics. And there's two scenarios that they gave where this is applicable. So firstly, where it's really challenging to collect those plastic or the small fragments, so the main large plastic or the fragments that are generated in the environment. And examples of this would be tree guards, but also agricultural products like mulch fill. And the second option, where it could be favourable, where it's really difficult to separate those materials from organic contaminants. So potentially things like tea bags, if they were disposed of within a organic waste stream. I think many parts of the UK doesn't have that facility at the moment, but if that sort of develops, that might be another case where it makes sense, where we can't separate those materials and it would go for an organic waste incineration. But what actually is biodegradation? So whilst I've said it's a favourable option, in particular applications, and there's already a wide range of products on the market that are biodegradable and sold as biodegradable, how do we actually define what we want from a biodegradable plastic? Over what time scale will something biodegrade? I think just saying biodegradable isn't enough. We need to know how long will that take and in what conditions will it biodegrade. Because our environments aren't the same. You've got a huge range of conditions, different temperatures, different UV, so light treatments, different microbial organisms present within the soil than you do with marine environments, than you do with marine sediment, and so on and so on. And also you've got fluctuations, you've got daily cycles, you've got seasonal cycles. So our environment is incredibly different. You can see on the screen what biodegradability is. So breaking it down, you've got your plastic, and it's the action of microbes that will break it down to its constituent molecules. So carbon dioxide being released, those microbes multiplying, and you also get some mineral salts. So that's a complete biodegradation process. But this isn't a universal feature. As I've said, the environment is incredibly different, and the properties of that plastic will also influence its rate of degradation, the additives that it contains. So, coming back to what Craig said about open questions, there are many open questions, and here's a case of it as well. How long will it take to biodegrade within different environments? We still don't know that for a lot of different biodegradable plastics that are in different environments. And are microplastics formed? And what chemicals come out whilst that product is degrading? We still don't have answers to these questions. There we go. Another thing to highlight is the associated ecological impacts. Now, there's general consensus among scientists that conventional plastics cause harm to organisms and to ecosystem processes. These could be physical, chemical, or biological. So we've all seen pictures of plastics wrapped around seals and seabirds. We all know that microplastics are formed and that animals can ingest those. These can have impacts on the animal, or it can be taken up by plants. It can also impact things like carbon and nitrogen cycling. But because the research into biodegradables is still relatively in its infancy, there are still a huge number of questions remaining within this area for specific biodegradable plastics. And something that's very unique to biodegradables is this: as they degrade, they might form degradation products. So intermediaries, before they reach their end of, the very end part of the chain, the molecules, other products may form, which are as yet not well studied, not well documented, and therefore we don't know those impacts. And really, before we start recommending and maybe using these products widely, surely we want to know the answers to many of these questions that I've just highlighted. Okay, so as we're at a forestry group, I thought I'd try and put a bit of spin about tree guards and shelters on this. And you might already know this, globally we use about 0.2 million tonnes of plastics within the forestry sector, and with the way that it's going, this is likely to increase with the number of trees that are being proposed to be planted within the UK, for example. And again, I'm sure you know a lot of this, but most of those tree shelters are made of conventional plastics like polypropylene and polyethylene that just get left in the environment. So this could be one of the prime examples where biodegradability could be an option if these plastics aren't getting recovered. But I just want to sort of highlight that currently there's no conformity standards for the application of tree shelters. So there are some products on the market, and most of those are tested against soil degradability standards. But if you think about how your tree shelter is used, there's only a very small proportion of that actually in contact with the soil. This is where the majority of the microbes are present. There's a lot less in the air around us. So the soil is where all the fungi and the bacteria live that are going to break down that plastic. Another thing to note is that we obviously want our tree shelters to last whilst they're carrying out the function that we want. But how long is that? Is that a few years? Is that 5 years? Is that coming up to 10 years? How do we define that time scale of when the plastic is useful to us, and then at what point we want it to start biodegrading? And another thing to note is as that tree grows, the conditions will change. So as it grows, it's likely to block out some of the UV radiation as the canopy develops, as the forest system develops around it. Depending on the types of tree, as the tree establishes, might it make the soil more acidic with the leaves that are being dropped? All of this also has an impact on how that tree shelter might degrade at the end of its life. So I think the important thing here to note is, at the moment, we don't have conformity tests that kind of tick box that this tree shelter will degrade in X amount of time in Y conditions. As I said, most are sort of based on soil conformity, and that's not how the shelter is actually being used. So, to conclude, for certain applications, biodegradables might offer advantages over conventional plastics, and one example is where they can't be recovered from the environment. But we need a lot more research into working out the rate at which these materials degrade, and what chemicals leach out, and any degradation products that also come from those plastics. We also need to focus on understanding the associated ecological impacts from those actual plastic fragments and those additives. And ultimately, by answering some of these questions, we can start to develop a risk assessment framework that will help us make more informed choices about what materials to use in what applications. For biodegradables, unfortunately, we're not here yet, but we are working in this direction, and I think kind of just wanting to highlight in this presentation a lot more of the unknowns than maybe the knowns on biodegradables at the moment. But I'm involved in some work at the University of Plymouth that are trying to answer some of these questions. So the Bioplastic Risk Project is led by the University of Plymouth, where I'm from, and what we're trying to do is work out how these materials degrade, what happens to them, what are the rate, do the chemicals come out, what impact does that have on ecosystem functioning and ecologically important species, to ultimately get to that point where we can understand the associated risks and help to make informed choices on material use. So I'll end there, and I'm happy to take questions if we've got time. Unfortunately, I can't stay for the whole day, so please grab me at the coffee break if there's anything else you want to talk about, or all of my details are on the screen. Thank you very much.